Okay, we're going to take a look at sequences, which is something that you should have seen in past classes. So this is going to be mostly, hopefully, a review for you and maybe a couple new things. So a sequence is a list of numbers written in an explicit order. So there's a first term, a second term, a third term, and so on. Sometimes you'll see that a sequence starts with 0 rather than 1. It just depends on context. The nth term refers to some arbitrary term somewhere out there. So if it was the 100th term, that would mean n equals 100. And we can think of a sequence as really a function. It's just all the input that you plug in are just these numbers. So you plug in 1, 2, 3, 4, and so on. Okay, so your domain could be finite, meaning you could plug in n equals 1, 2, 3, 4, 5, and you would have a finite sequence. You'd have 5 terms. What we're going to be concerned with mostly is infinite sequences, where those numbers just keep going on and on and on forever. Okay, we can have an explicit sequence, which gives us the whatever nth term we're looking for directly. So if we're looking for the 100th term, you just plug in n equals 100, and you can figure out what the value of that term is. So we plug in 100, simplify that down, and we know now that the 100th term is 1 over 10,001. If a sequence is defined recursively, that means in order to find each term, you need to know the term or terms that came before it. So if the first term is 4, and the nth term is defined as b sub n minus 1, which means, say, you have the fifth term, b sub n minus 1 would be the fourth term, it's the term that comes before, plus 2. So we know b sub 1, that's given. B sub 2 would be b sub 1 plus 2, that's 6. B sub 3 is b sub 2 plus 2, that's 8. And you could continue on as far as you need to. An arithmetic sequence is a specific type of sequence where each term comes from adding the same value. We call that a common difference. It's the difference between two consecutive terms. So in this case, we go -5, -2, 1, 4, 7. Each term is 3 more than the one that came before it. So if you ever take a term and subtract the previous term, that difference is 3, and we use the value d to define that. This one may not look arithmetic at first, but we have to think about how logs behave. If you take the difference of two logs, that's the log of the fraction. So the difference there is natural log of 3, and it turns out it's going to be natural log of 3 for all of those, so that actually is an arithmetic sequence. We can define these recursively, so the nth term is the term that came before it plus that common difference. Or explicitly, the nth term is the first term plus that common difference times n minus 1. And this should make sense if you go and add that value d plus d plus d plus d over and over and over again. Well, repeated addition is multiplication. A geometric sequence is one where you're multiplying by the same thing each time. We call that the common ratio. It's a common ratio because if you took a term and divided it by the term that came before it, you'd get that value, which we use r. So every time you go from one term to the next, you multiply by -2. Every time you go along this sequence, you multiply by 10. To define a geometric sequence recursively, to find the nth term, you take the term that came before it, you multiply it by that common ratio r. And explicitly, to find the nth term, we'd take the first term, multiply it by r to the power of n minus 1. And that should make sense because we start with that first term, we multiply it by r times r times r times r times r, and we use exponents to shorten repeated multiplication. We can talk about the convergence or divergence of a sequence. The convergence or divergence of a sequence refers to whether or not the values of the sequence as n gets bigger and bigger and bigger approach a certain value. So if we want to know if this sequence converges, we can take the limit as n goes to infinity. As n approaches infinity, that -1 is insignificant. And so this thing is going to approach 2. So we would say that this sequence converges to 2. So converges means it approaches a specific number. In this case, that number is 2. We want to know if this converges, so take the limit as n goes to infinity. We can use an algebraic manipulation here, rewrite e to the 3n as e to the n times e to the 2n, so we can cancel. Now as n gets really big, the denominator is getting really big, this top stays constant at 1, so this approaches 0. This sequence converges to 0. Take the limit as n goes to infinity for this one. Well, we can cancel out an n. Limit as n goes to infinity of 4 times n. Well, if n gets bigger and bigger, this just gets bigger and bigger. That approaches infinity, and we would say that this sequence diverges because the terms are not approaching a specific value, they're just getting bigger and bigger and bigger. Okay, we want to know if this converges. So we have to think about what happens as n gets really big. Well, as n keeps on getting bigger and bigger and bigger, sine of n bounces around somewhere between 1 and negative 1. So we end up bouncing around between positive 4/3 and negative 4/3, never approaching a specific value. So we would say that this sequence diverges. Okay, the absolute value theorem for sequences. This says we can take the absolute value of the terms of the sequence, and if the absolute value of the terms approaches 0, then the original sequence also approaches 0. So notice this is only true if the absolute value of the sequence converges to 0. If the absolute value of the sequence approaches some other value, this theorem does not apply. So here we have negative 1 to the n over n. And it might help to think about what happens as n gets bigger and bigger. As if we have n equals 1, this would be negative 1. If n is 2, it would be positive 1/2, then negative 1/3, positive 1/4, and so on. So it might be helpful to just take the absolute value so we don't have to worry about that negative. Now we have the limit as n goes to infinity of 1 over n, which is clearly 0. And by the absolute value theorem for sequences, this means the original sequence also converges to 0. All right, let's take a moment to think about this. As n gets really big, we have that square root of n to the 4th plus 1 in the denominator. Well, as n gets really big, that plus 1 is really pretty insignificant. So we can drop the plus 1. The square root of n to the 4th is n squared. So we make this look a little bit nicer here. We can cancel out n squared. Now, the absolute value theorem doesn't apply here because this limit, if we took the absolute value, doesn't approach 0. These terms bounce around between 3/2 and negative 3/2, so this sequence diverges.